Welcome to dproject screen to world. In this video, what we're going to do is we're actually now going to find out, as we look around with the camera, what the world space direction we are looking in as a unit vector is. You can see that logged out to the console. So let's do it. So it's time to do this deprojection thing. We're going to work out what the screen position that our crosshair is effectively pointing at is, which will be fun. So the method that you need for this is on the player controller. We've got something called deproject screen position to world on the player controller. So there it is, and there is its signature. Now it doesn't tell you what this world location is. It's actually the camera world location. We don't need that, but we need to provide a variable so that it can spit the camera world location into it. So that's what's going on there. Screen X is the screen X position, screen Y is the screen Y position, which we've just calculated both of these here. And they're all wrapped up in this screen location, but of course we can do a .x, .y to get those out. And then the world direction is the thing we're looking for. We're looking for the direction that we're looking in, so we can line trace down that. So that's what I want you to do, actually. I want you to do the deprojection yourself. Look up that method, deproject screen position to world. Make sure you've got the one that I just showed you that's here on the player controller, because there is another method that sounds similar. In fact, there are two others. One's in gameplay statics, and I've forgotten where the other one is, but this is the one you want anyway. That's the method. Look up the method signature online, or just go back in the video a second to where I just had it and spoke about it. Log the world direction it returns. So use the method and log out the world direction to see if it makes sense. And ignore world location it returns. It's actually the camera's world location. Camera world location may be a good name for the variable, but we'll just discard it. So go ahead, pause the video and see if you can get that working now, please. I say please, it's please for your sake more than mine. Really, all the learning happens when you do these challenges. So please go ahead, pause the video and give it a crack. Welcome back. Okay, let's get this thing done. So we need an F vector, or it could be an auto, but let's just be explicit this time for fun. Let's go F vector, camera, world location. I said we're going to have to throw that away. So there it is. Now we're going to do the actual deproject. So how do we do that? Well, it's deproject screen position to world. There you go. That's the one. Now, what does it take in? Well, it wants a screen X position. So that is viewport. No, it's not. It's screen location dot capital X. Small lowercase x won't work. Screen location. Oh, hello. Dot capital Y. So that's giving it that. Now, it wants a world location. That is this camera world location thing that we talked about. So let's give it what it asked for. And then finally, it wants to give us a world direction. So let's just use something called world direction, and then let's make ourselves another F vector temporarily for the world direction. Ultimately, this is probably going to be refactored into another method, but so that we can see that this is working, let's just make another F vector. I won't put it on the same line as the one above, as we're going to remove this one, probably. F vector world direction, okay? And then that gives us something to pass into the deproject position to world. Now, that's a Boolean type that comes back from this, remember. So we can actually say if deprojects screen position to world, i.e. if that works, do something. What are we going to do? Well, we're going to do a famous log to make sure it works. So here is the log entry above, which I can just copy, and we're going to come in and say, now, is it the look direction? I think it actually is the look direction. Yeah, so that's good. The reason I'm not returning this value yet, by the way, is because we haven't actually got the hit location yet. So I'm just debugging that we are looking at the value of the world direction. We need to do a little bit more work. We need to actually do the line trace here, as per the comment, before we end up with the hit location. That's why I'm suppressing this logging at the top here, because we are still working through step by step. So we're saying if that, and in doing so, you're actually doing this deproject, then tell me what the direction you found was. Otherwise, don't tell me anything. So that's what we're doing. Let's have a go. I'll leave my code on the screen while it compiles. I think that's probably more helpful for you. I hope that you didn't get too tripped up by the fact you need a capital X and a capital Y on the dots there, or even indeed on just accessing those members in general. And I hope you didn't get too thrown off by the camera world location thing. How are we doing? I think that worked. There you go, look direction. Now let's ask if it makes sense. So just before I even start, let's see what we'd expect. The tank is pointing down positive X, Z is above us, Y is to the right. So If we face forward, we get an x value of 1. If we face to the right, we get an x value of 0. And if we face behind, we get an x value of -1. Okay, that sounds feasible. Let's have a look at the y's now independently. Y is 0 facing that way. It is 1 facing to the right. I said y was to the right. That sounds good. 0 and -1, yep. And then the z. If we look straight down, z is -1-ish. When we look horizontally, z is 0-ish. And when we look up, z is 1-ish. Great, so we have the components of these vectors. Look at this little guy down the bottom of the screen, the actual axis indicator down here. Where basically it's telling us what proportions of this we have in each look direction. So if we're looking straight down x, we have a vector that is 1, 0, 0 for all the way down x. If we're looking equally in x and y, we end up with something that is not 1, 1, 0. So the reason we're getting 0.7 something by 0.7 something here, or where does it even out? 0.707, there you go, is because, if we have a look at a calculator, if we take 0.707 and we square it, we get 0.5. So I'd have to draw you a diagram, but it's simple trigonometry that if you want the vector to be a total length of 1, then it needs to be 0.707 down either side, because 0.707 squared, which is 0.5, plus 0.707 squared gives you 1, and the square root of 1 is 1. Remember, the square on the hippopotamus is the sum of the square on the two opposite squirrels, or whatever the thing is. So basically it's Pythagoras. That's why this happens. You're always getting a unit vector is the bottom line. The vector that you get out of this is always of length 1. So if you start giving it some z component, the other vectors will also shorten appropriately. All right, so that's what we're getting back, a unit vector in the direction that we are looking. I think I'll leave it there for this video. That was short and sweet and simple, but it's pretty good that we now actually have that direction. So what we'll go on to do in the next video is, actually, I'll tell you what, just before I dive out, I think I'm going to just factor this out, because this method's getting a bit chunky, in my opinion. So let's just quickly factor out this whole deproject screen to world position into a different method. I think that would be a lot neater. And I think what we're doing in this method is we're getting the look direction. So it's going to be bool, because we want to know if it worked. A-tank player controller, and then get look direction. And then what do we need to take in? Well, we're going to need the screen location for this guy to work. So it's going to be an f vector 2D screen location. And it's going to be an f vector. We're going to make ourselves an out parameter. Ampersand, because we need a reference for this out parameter. World direction. Or, to be honest, we ought to call that look direction. Let's have a name change here to be consistent with the name of the method. Okay, so that's what we want. Now it's complaining because we haven't yet declared this method in the header file. So let's go over to the header file, make a quick declaration. And in our declaration, we've probably realized that it should be const. Getting the look direction should not change any of the member variables of this class. So const, back to the implementation, make it const. I'm simply doing a refactor here. I'm doing it manually because I too often use on Visual Studio tools, and you poor guys on Xcode don't get the same deal. So I'm going to do it this way. All right, so when we actually call this method, what do? Well, we set up a camera location and a world direction. So let's just take all this code, pop it in here. Now, we don't need world direction. Indeed, it's not world direction anymore. We're calling it look direction. That was the name change, so I'll replace that. This is for discarding, to be discarded. But it must be passed in, so camera world location must go in there. Look direction comes in as a reference, as an out parameter. Then we need to actually do the gproject, which we do. So take the if off, like so. And then I may as well just log to test. So very simple thin method. It just does the deproject. It gets the look direction. If you want, by the way, with these types of methods, to make life easier and to make it easier to read with these multi-parameter methods, you can, of course, do what we've done many times before, which is just space things out onto multiple lines. That, of course, makes everything just that much easier to read. Okay, so that's done like that. So, deproject screen position. Now we can go back in and say, well, instead of if and then the whole thing, we can just say if get look direction. And then, of course, we pass it the things that we needed, which is the screen location and this look direction, like so. So if that succeeds, then go ahead and just log out where we saw. So it's a simple refactor out here. You could argue that's hardly worth doing, but I think it just makes it a little bit more self-documenting, and it helps us practice how you refactor these slightly trickier things that need out parameters. Of course, the final thing we need here is an F vector look direction, because it's about to be used as a out parameter here. We're not yet doing anything with that look direction, but we will do something with that look direction shortly. We're going to use it here. I'll just make it look exactly the same along that look direction. Okay, now let's see if this compiles. It's getting a couple of complaints, but I think they're just IntelliSense errors. If not, the compiler will give me a much more useful error. I'll leave the code on the screen so you can see the refactor that I've done. Can't see anything wrong, but I'm sure there is something. Okay. Look direction undeclared identifier on line 55. Aha. Spelling error. Okay, let's try again. We always get an error on UE logs, of course, as I've mentioned before, because Visual Studio doesn't understand these macros, so we have to live with that. I'm not quite sure why I've got an error down here. It's probably glaringly obvious to somebody out there, but I can't see it. And it should be look direction, not world direction. That will teach me for renaming variables. But on the other hand, it is worth renaming things because we want to make sure that things stay very meaningful. So don't be shy to rename things. And on line 72, I'm missing a closing brace, and that is just because I've got too many of them. That's what the complaint has been. I have too many closing braces. Finally, I think this will compile and hopefully work. So you can see how long it can take to refactor things out, but at the end of the day, I think it makes it easier to read, and it will make sure that our get site array hit location method here doesn't blow up too large. It's already that big before we start doing the line tracing, and this makes sure that it kind of stays on a screen. And finally, get look direction must return a value. Of course, it must, and that's because I haven't returned here. Okay, so lots of errors on my behalf there, but you get to see what a just eaten a big carbohydrate dinner type coder behaves like compared to the normal sharp self. So you can excuse yourself if it takes you this many compiles to get something working, because occasionally it takes me that long too. All right, let's take a look and see if it looks feasible. It does. The vectors are coming out okay. And the code I shall leave on the screen there for you. And that's it. We've refactored, we got it working, and in the next video we'll actually do the line trace.